Welcome to the Jack Westin MCAT podcast with your hosts, Michael Maleka
and Molly Hudash.
Hello, everyone, and welcome back to another episode of the Jack Westin MCAT podcast with your hosts, Mike and Molly. Today's episode is going to be a pretty special one. I really feel like I say special and exciting in most episodes, but this one truly is. All of them are, but today we're talking about MCAT math, which I think is one of the most feared things on the test, right? Like, taking content aside, like, so many students are so intimidated by calculations on the MCAT, and I think this is one place where so many students can make significant strides if they change their approach. So I'm excited.
Yeah, I love how you were like, I'm not going to say I'm excited, but then you're like, oh, I'm excited.
Oh, I am, yeah.
I think every episode hits on a weakness or a place of struggle for a lot of students. I know people
By
join the free
design.
trial by design, right? Every week we hold these like free trial sessions, and I always like talking about like the podcast there, and I always like asking like, oh, what's your favorite podcast episode? And I love how every single person says a different episode. Like they're
Yeah.
all like, it's all like, and there are some common ones, like people love the enzymes one, people love, on the Anki one,
Metabolism.
the
Yeah, the Anki
metabolism
one.
people really liked. But that's
Mhm.
why I think every episode is so special, because there's somebody out there struggling with this one. But this episode in particular, I
Yeah.
think, is one that I think most students that we've met struggle with the most. Like when we think about like our topic today, which is math on the MCAT, sweats.
Yes.
We also give a free trial session on MCAT math, and when I ask people what they think, it's like dying, vomiting,
Yeah, I
all these visceral reactions to MCAT math. Very few people, like really the minority,
Yay.
actually
Oh,
like math on the MCAT. And there's a lot of reasons why that we'll go into. But our goal today is to change people's mindset about MCAT math.
mhm.
There are some things that people think about that push them away from math on the MCAT. Things like not having a calculator, which we'll dive into. Things like that, where it's like, oh, because I don't have X or because of X, I struggle on the MCAT when it comes to math. But
Yeah.
we want to change people's minds today to think
Yeah.
these are actually good things. And how do we use the tools that we have to
Yes.
actually excel in math? Because truly, 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 and I mean this wholeheartedly, math on the MCAT, I'm gonna get back on this, is not that hard.
Oh, it's not that bad.
I'm going to, it's not that bad. It's honestly the only reason people think that it's bad or view it as bad or feel that it's hard is because a lot of times we make it way more complicated than it
Yeah.
needs to be. Way more complicated. There's a saying, like with tutoring students, I've had many students over the time. There's a saying that I kind of like came when it comes to MCAT math. It's always, it's not that deep. It really is not that deep. It's not as hard as we're making it out to be. Where as
Yeah.
long as we know what tools, know what to look for when it comes to math on the MCAT, like a lot of these questions go from 2-minute, 3-minute questions to like 20-second, 30-second questions. And so that's our goal today, is to take you from, oh my goodness, math is the worst, math takes so long, to math's not that bad. It's not that
Yeah.
deep.
Yeah. So this is something that requires practice, and it
Mhm.
requires rethinking
Mm.
how to approach a question like this, right? Like, math on the MCAT, if you try and do every single step and do the long division and do all of, every step of your work, it's going to take a long time, and it's going to be hard, and you'll probably make a mistake because you've got 12 steps that you're showing.
Oh my goodness.
It becomes not that deep when you recognize what you're actually being asked to do and you simplify as much as you can. Okay, so that's what we're going to talk about. It's not that math is easy, right? And it's not that if you're struggling with math, that's silly, right?
Mhm, mhm.
But it's that there's an opportunity for really significant growth right here, because if we change how we think about MCAT math, and when we internalize what we're really being asked to do on MCAT calculation questions, oh my gosh, right?
Mhm.
It becomes infinitely easier, right?
Infinitely.
Which is what we want, right? And I think this episode built really well off last episode, right? We talked about MCAT questions in general last episode and how best to approach them, how best to reason through. Obviously, calculation questions are a specific subset of just MCAT questions in general. So you're going to see a lot of similarities in how we approach those questions, right? We're going to read the question. We're going to make sure we understand it. We're going to think, what resources do I have to answer this question? What is my objective in the question? How can I best reason through the answers? That being said, math is a very specific skill. So we're going to start still with what a lot of us are probably doing right now. And then we'll work through really how should we be thinking about MCAT math, right? And how can we walk through a calculation question in a way that's going to set us up for a quick and easy calculation rather than a long and frustrating or difficult calculation. And we've got some little tips and tricks to share. So let's first set our scene, right? Let's assume, right? We're right at the beginning of September. We have a couple students that are testing in a week or two, but a lot of us are coming to the MCAT for the first time, preparing for 2026. Let's talk about some things that students might be thinking to themselves or experiencing when, let's say, they sit down for their first full length. How is MCAT math going to feel?
The first time, always, and I remember my first exam so viscerally, it's the worst experience ever initially, because it's so different. There are some things that you come upon that you struggle with so heavily. One of the first things that were kind of a little bit shocking first time when I sat down for an exam was not having a calculator. Right? That was one of the biggest things. Doing math without a calculator. I remember when I was in undergrad, I took math in undergrad, I took math in high school. Even the simple calculations, I got such in a habit of like 5 divided by 2. I would still put it in my calculator
Just
when
for
I'm doing my
confidence.
exam, just to double check, just to have it.
Yeah.
I can do that math on my own, but I always loved having the security of having a calculator. Just be like, oh, I'm not making a mistake. We
Mm-hmm.
don't have that on test day. This is kind of a habit that we'll have to kind of get used to and shake that, oh, we don't have that calculator for that security. But also, when I had messy numbers on my exams, when on my tests, I would just, hey, put in my handy dandy calculator and it would do all the work for me. Also not the case here, where on this exam, you do not have a calculator to deal with, to have that certainty of the easy stuff or the more straightforward stuff, or to handle the more complicated stuff for us.
Mm-hmm.
But while a lot of us view that, right, as an issue, we'll actually talk about it later. It's actually a good thing that we don't have a
Mm-hmm.
calculator. But that's one of the first things, right? If you are listening to this and you're like starting your studying, you do not have a calculator on this exam, right?
Mm-hmm.
First and foremost, okay? Um, so what else might a student find on that first test that it might kind of shock them, other than not having their calculator, Molly?
Well, I mean, I feel like when you find out that you don't have a calculator, students go one of two ways. And for
Mm,
me, I mean, it was nerve-wracking not having one, but for me, I would lean on my calculator less than most people.
mm,
Maybe for like the quick stuff just to double check, but I actually for the longest time, if you like had the option of having a graphing calculator or a scientific, like I just kept with what I had. I didn't want to spend $150 on a graphing calculator. So like I got very used to like simplifying complex math until it was easy to plug into a scientific calculator. And
mhm,
then I didn't really learn to rely on the like fancy calculations that
mhm,
a fancy
mhm,
calculator could do. And whenever I would try and put complex math into a scientific calculator, I would always mess up. And so
mm.
like when I heard there was no calculator, I'm like, cool, everyone else is gonna have to struggle through the math like I am. But I think most people when they hear that, whether you fall into my camp of calculator stress me out from the beginning, or Mike's camp of like I put everything in my calculator, pretty much every student goes one of two ways.
Mhm,
The fork in the road appears,
mhm,
right? No calculator, shoot, that's scary. I'm going to make sure I show every single step and I'm going to
mhm,
slowly simplify and digest this math problem until I find the perfect answer to
mhm,
8 significant figures, right?
mhm,
Or okay, no calculator. I'm just going to do the entire thing in my head. And it's very interesting. Students really do fall into one of two camps here. It's rare that someone finds that middle ground from the beginning. But both of these can be problematic, right?
Hmm.
If you work through every single step and you show all of your work, one, it's going to take a
A very long time.
long time, way too long. And two, sometimes the more steps that we add in and the more exact we try and be, the likelihood goes up that you're going to accidentally, move a decimal place, or you're going to
Mhm.
forget that that's an exponent and you're going to multiply it. Like, the more complicated that you make it, the more opportunities there are to make a mistake, right? That being said, if you do the entire thing in your head, there's also a high likelihood that you're going to make a little mistake there, especially because you can't even see it, right? Oftentimes when you get a question wrong and you've just done it in your head, you have no ability to go back and like, how did I think about it? Because you have nothing on paper, right? It's all
Right.
just done in your head. So you can't really figure out where along the way you went wrong. Um, so those are both things that are symptoms of maybe not having the most solid MCAT math strategy,
Hmm.
right? We want to find that middle ground. And that's what we're going to talk about today, how to find that. But I think those are both things that students really lean on, um, because they don't have a calculator, and it's hard to figure out how best to approach questions like this.
Right. And there was one thing that you hit on that, like, I know I resonated with a lot was like the doing math in my head. I was never one person that like felt the need to like write out every step, but because of that, I would be like, oh, let me just do it in my head. Then this seems easy. Sure, I don't have the calculator. Eventually got used to not having a calculator, but then I'd be like, oh, I can just do this in my head. And I cannot tell you how many mistakes. Like I'd be like I would say silly mistakes I would make because I just felt like, oh, I could do the math in my head. Then when I look back, I'm like, oh, that was so silly of me. But in
Yeah,
reality, it wasn't just me being silly. Like that's why we talk about this in MCAT
I know.
question
You said silly
strategy.
mistakes. I'm like,
And I was like,
Mike.
Mike, yeah, exactly. It wasn't a silly mistake, is the
Yeah,
thing, right? It was a symptom of not having a proper strategy, right? I would think it was a silly mistake. And I'm sure it's people here and like, oh, I make silly mistakes all the time. No, the reason we make silly mistakes are usually system errors. That means we have
yeah,
to change our system, which is our goal. So again, I wasn't so much the right too much. I was definitely the too much in my head kind of guy on
yeah.
that end of the spectrum. But speaking of things that we struggled with, like I know I struggled with another thing, especially initially, I struggled with a lot, and that we find a lot of people struggle with is maybe, they don't have a problem when actually doing the math. If they actually get started, they can get going. But a
Hmm.
huge problem that we find is, or a huge thing that we see that people struggle with is not knowing which equation to use, right? Where you start a problem, you're like, okay, I'm going to do this problem. Okay, I can, if I know what to do, I know I'll do it, right? But then they just
Hmm.
don't know what to do. Like, oh, I'm seeing a
Yeah,
problem. I'm like, I look at a problem, I'm like, where do I even start with this? Which equation do I use? It's so interesting how ubiquitous this, but like, this isn't something that we see once or twice. And again, I know this because again, we talk to students in our free trial sessions.
yeah,
I ask like, how many people sometimes just don't know where to start with a problem or
yeah,
don't know which equation to use? Like I've got like 150 people in this call, like over half say yes, and I'm like,
yeah,
oh, this is a ubiquitous problem. So
yes, yeah,
100%, this is a huge thing that we struggle with. Again, symptom usually though of not having a proper system usually. um
yeah.
I mean, what are your
And
thoughts on it?
yeah, I mean, I think a lot of students think I don't know which equation to use, and so that's my problem. I just need to stare at an equation sheet some more. But I
Mm,
would say more than half the time, if students don't know what equation to use, it's actually because they're not comfortable enough with the units
mm,
to know what they're given.
mm,
Because if you could figure out what you're given, like, oh, I've got velocity and acceleration and time. It's like, okay, you could see a common theme and you could start to think of what equations do I know that include that, right? Um, that is the step that I think a lot of people are missing. Yes, you do need to know equations, right? You got to. You have to learn them, but just knowing an equation sheet is not enough. We'll talk about that as well, but I think if that's your main symptom, I don't know what equation to use. Our instinct is go stare at an equation sheet, and
mhm.
sometimes that's actually not helpful.
It's not
So,
helpful at all. In fact, most of the time it's not helpful. In
yeah.
my experience, most of them it actually is really not that helpful.
Yeah. Unless you are super solid on literally every other step and that's your only weakness. But again, it's kind of like when we talk about passage reading strategies, especially in cars, because I teach cars office hours every week for our course students. A lot of students are like, timing is my number one issue. like, if I took the timer away, would you get 100%? Would you
Mm.
get 80, 90%? And they're like, no, definitely not. I'm like, okay, well then it's not timing, is it? It's like
Right.
timing is the scapegoat. I think thinking I just haven't memorized my equations well enough is the scapegoat of MCAT
Mhm.
math.
Right.
But again, there's lots of other things that could go on. And to be honest with you, I think one of the least obvious problems that you might have with MCAT math is actually leaning on the math and the calculation too heavily.
Yeah. Yeah.
Because there are a lot of MCAT math questions that are actually more so conceptual questions that
Mhm.
you can reason through without picking up your pencil, right?
Mhm.
Like they're asking you what seems like a math question. And in fact, in the MCAT math free trial session, the first question that we show you is a really good example of this, right? Like
Mhm.
you could use a calculator and do a couple steps, or you can lean on, it's an enzymatics question. You could lean on your definition of Km and Vmax,
Mhm.
and you could actually get the answer without touching your pen,
Mhm.
right? So it's don't jump immediately into the math just because you see numbers, okay? See what you can do first, set the problem up, see if you even need to do calculations at all. Sometimes
Mhm.
common sense can get you pretty far. Um, and of course, right, know that you've got tools. If you need the math, you know how to do the math, or you will
Mhm.
after
Yeah.
you finish this
After
podcast.
today, after
Yeah,
today, right?
you can lean on skills like that, but it's good to see first if it's necessary because it may not always be
Right.
necessary.
I think this was one of the most overlooked issues, and I say issues, but overlooked struggles, because a lot of people don't see that as the problem. They saw the problem and then they jump to the math, in our eyes, way too quickly. But then the worst thing, because usually the solution shows them the math way to do it,
Hmm.
which is why this problem is sometimes hard to self-diagnose, because the solution makes you think it's actually a math problem, and they show
Yeah,
you with the equation, you're like, oh, I should have thought that way, when in
yeah.
reality, like, a lot of the times the issue wasn't the math itself, it was that you jumped too quickly to it, that you didn't actually think about what the problem was asking you to. I remember I had this one student. She was amazing. She was actually really strong at math. She was like didn't have a typical science background. I think she had an economics background. So she was very strong at the kind
Oh,
of the core math.
interesting.
Yeah.
Mhm.
And yet she still struggled with math problems so much. And I was like,
Know
okay.
too much.
And I was, you know too much. So, and I'd be so like, that's kind of like counterintuitive. Like you would think, oh, you got an economics background. Again, the core things you need to know: addition, subtraction, multiplication, division for the MCAT. Like that's what they do. Like that's all they do, really.
Right.
Um, but when we actually looked at how she was doing math problems, the problem wasn't when she was doing the math. The problem was she would jump too quickly to the math. She would rely too heavily on the math, where in reality, if she just thought about if she just understood what the problem was asking, she's like, oh, most of the time, she didn't even need the math. Where, oh, you could
Mhm.
just, there was one answer that, there's like three that just can't be right, and the only
Yeah,
one that can be. So I, yet when we talked about it, she was like, oh, I had no idea that's what I was doing. So
yeah.
this is a really good point of like self-reflection for anybody listening. Like, hey, this is probably something you've not thought is the issue, but think about, go review your math problems. Well, after you do them, ask yourself, was there a non-math way for me to do it? Or was the only way for me to do it was math? Sometimes that is the case, but
Hmm.
be aware those kind of problems are more common than you might think.
Yeah. And to give
Mhm.
you an example, right?
Mhm.
Like if let's say that you were given a thermodynamics problem, right?
Mhm.
And let's say that they give you the setup and you know just from the read that you are looking for a spontaneous reaction. So it'd be negative delta G,
Mhm.
right? And let's say that you know that that should be a really big number, right? Like, oh, it's very strongly, there's like an explosion because it's so sudden because so much energy is released. If you look at your answers, two might be positive delta G, those are out, and two might be negative. Maybe one is -1, and maybe one is -1,000.
Mhm.
Like, okay, it's not the positive because you know it's spontaneous. And if you know that it's so incredibly spontaneous, right? The reaction wants to happen so bad that literally as soon as you mix the reagents, it explodes with energy. It's probably logically
Nothing.
the -1,000, not the
Mhm.
-1,
Right.
right? Like I didn't, could I have calculated that? Sure, if numbers were there, I could have used math, but I didn't need math for
Mhm.
that.
Hmm.
I feel like it's good to have an example to see like what to look for, right? Because sometimes you can reason your way through and either get to maybe one or two or three options from four, or you just can reason through and say it's probably this one and then move on, right?
Right.
That question could take you a minute and a half, or it could take you 20 seconds,
Right.
depending on whether you immediately jump to the math or whether you look first and see what you're dealing with.
Yeah. But then if you look at the solution will show the math away, which is like
Yes.
the heartbreaking part a lot of times where it's like, oh, sometimes these solutions, again, they're not wrong, but they just
They're
show
correct,
they're
but yeah,
correct. Just showed like the long way to do it. So, but
yeah.
yeah, that's
That's why I love
definitely
our solutions.
that's why we love our solutions over at Jack Weston, where we kind of really focus on the conceptual way to do it. If math is required, yes, that will be there,
Yeah.
but the non-math way
And
is
we'll
always
show the
better.
math way anyways, right? We'll
Sure.
show the long and the short, but like learning the little
Sure.
quick tips are
Mhm.
so
Yeah,
helpful.
yeah,
Um,
100%.
because it's easy to get stuck, right?
Mm,
Like especially well, whether you are or are not using math directly, even if you're reasoning through, it's very easy to get stuck and then panic. Like,
mm,
I don't know what to do. Maybe you solved it and maybe you got an answer that's not one of the four options and you panic. Maybe you get halfway through and then realize, I'm not prepared to do this math. I don't know how to do this math. What is, the negative log of 5.4 times 10 to the minus 6? Like, I
mm,
don't know how to do that. I don't know
mhm.
how to work through this and then panic, right? And give up, right? And we talk a lot about question strategy and exam strategy. And if you're taking a real test, right, like your actual exam, or you're taking a full length and it's timed and you panic, sure, if you want to flag guess, move on to save your energy for other questions, no problem, right? But if you have time to come back to it, or if you, right, are doing untimed practice, take a quick breath, right? Reread the question and see, just read over your work, right? Or if you've been doing it in your head, try writing out your work, right?
Mhm.
Look back over. You've probably looked past a way to make this infinitely simpler for yourself. If you're ever doing really complex math, that should be a hint. There's a way. There's an easier way.
There's usually an
They
easier way.
they design the numbers to look kind of nasty and hard to deal with, but they almost always simplify or cancel out, or like vast majority, and this is wild, vast majority of MCAT questions end up being addition, subtraction, multiplication, and division. And that's it. And you should know how to go from a fraction to a decimal and back. That's pretty much the extent of actual math knowledge that's necessary. Logs too, which
Mhm.
you
The
simple
logs,
YouTube video or a lesson in our course and you're fine with logs too.
right, right.
Basic logs.
We actually cover it also in the free
FTS.
MCAT math session
Yes.
that we hold every Wednesday.
Yeah.
We do alternate science and math, but we make logs like so disgustingly easy during that
I know.
session.
I love it. I love
I
it.
know it's like if you are like somebody that you're like listening to this right now and you're like,
Come find
you just
us.
said logs are easy and logs are like my worst enemy ever. Like go on the Jack West website, sign up for a free MCAT math session, and like I can promise you, I can swear to you, I get on everything. People don't trust me when I say this. Logs will be easy by the time that class
Yeah.
ends. I can promise you that. Um, but that's also really hits on like that whole getting stuck idea. Sometimes we get stuck because we miss something, but sometimes we get stuck because we're afraid that we don't know enough. We're like, I
Hmm.
don't know enough to do this problem, right?
Hmm.
Where a minority of the time that is true. But most of the time, especially when we work with students all the time, most of the time you had all the tools that you needed. But because we were afraid, because our initial thought, right? We've all had that initial thought when we saw a problem. We're like, oh no, I don't know how to do this. Before we even actually try the problem out, we defeat ourselves,
Yeah.
right? Well, before we even go into the problem, I want most people, everyone really to recognize you always know more than you think. You
Mhm.
always do. Right? And this is so true. And there's a little bit of cognitive dissonance I feel with some students because sometimes they see the solution, they're like, oh, there was nothing new in the solution for me. I had all the tools I needed. Right?
Mhm.
But then why are we thinking that we didn't have enough every time we see a new math problem, even though at the end there was never anything new that you needed? So I
Yeah.
think going I think, well, how do I want to say this? Being afraid when you go into MCAT math is a lot of the times the reason that we're struggling. Not because you don't know enough. You know, you have all the tools that you need, but we're kind of defeating ourselves before the question starts. So, one thing I really recommend, have faith in yourselves before you start even a math problem. We're going to give you so many tools, we're going to give you so many steps. But the first step is believing you can do it in the first place. Right? Believing you can do it in the first place, and then you can use all these tools and everything. But if you don't even have that at the beginning, no matter what tools that you have, it's not going to work. So have faith in yourselves. And again, then you can actually use these tools to do MCAT math.
Yeah.
Mhm.
It reminds me so much of Cars,
Mm.
right? Which is obviously there's no math in Cars. It's completely different, but I feel
Most
like
of the most of the time.
yeah, that one question
There is
in
one question.
QPAC. Yeah, the very end of QPAC 1, there's a percentages question. I was showing Mike because I did the video solution for it. I was like, you have to figure out like what percentage of or what is the likelihood that this like French child from the 1800s will
Will die.
pass away before their mom because there's data in the past. Okay, not
Totally.
usually any math in Cars, but I feel like it's an analogous issue where because we don't expect that we can read a Cars passage effectively, and because we get so intimidated by how it looks on the surface, you actually create a self-fulfilling prophecy.
Mm.
You decide that you can't do Cars and that you don't have the tools, or that you're not good enough as a reader, or that, you know, the fact that you're an ESL student means that you can never succeed, and you won't, because you won't see the opportunities to make things simpler for yourself or to harness the tools that you've learned and developed because of how much you're scared of it, right? And it's the same thing with math. If you see a math question and immediately, you know, heart rate, blood pressure spikes, you got sympathetic activation, and you tell yourself, I will just get this wrong, like I can't do this, you won't see the many ways to make it simpler, right? So you have to, even though it's scary, you have to open yourself up to relearning how to approach questions like this, right? Because maybe with your current mindset, you wouldn't get this question right. Maybe, right? But that doesn't mean you never can. It takes unlearning how to approach something like this and relearning. And at a certain point, with practice, after changing that mindset, you'll find that you're actually excited for MCAT math questions, right? Or you might be excited for Cars, right? It comes from having a toolkit that is effective for the task at hand, right? Not for an idealized version of it, for what you actually have to do. And then getting practice with it, right? With practice will come confidence, and you will basically, you know, stop that self-fulfilling prophecy from swaying your score and from swaying your confidence as well. So what is this mindset that we're going to talk about, right?
Right,
We
yeah.
mentioned not having a calculator is actually a good thing, right? I feel like that's pretty profound and pretty weird, but the same thing that we were talking about with the last episode that we released on MCAT math, or on MCAT questions as a whole, the same thing applies, right? We talked about with every single question, you are not given a blank space to write 3 paragraphs, right? You're not expected to be able to regurgitate the perfect answer to every MCAT question. The beauty is this is a multiple choice test, right? You have 4 answers to pick from. And the answers for a general MCAT question can give you so much direction. I'd argue that the answers for an MCAT math question give you even more.
Even more.
Way more, right? So especially with calculations, the way that we're trained in undergrad from statistics class or calculus or algebra or whatever you were doing, you had to show all your work and you had to come up with your own answer to X amount of significant figures or significant digits. Like you had to be very precise. Here, your job, pick the best out of the 4 options. You don't have to come up with your own answer. You just have to figure out which of the 4 that you've given me is most reasonable. And that alone changes everything.
Pure game changer.
Everything.
There's so much that's different about math on the MCAT than before. Like there's so much different. You don't have a calculator. The answers are right in front of you. Most of the times it's the exact opposite beforehand. You had a calculator and it was just a blank space. Okay, and then you go with an answer and then you circle that one with like a red color or whatever have you. Right? But yet a lot of people tackle math on the MCAT with the same mindset that they had before. Right? And they're like, why am I struggling? No, we're struggling because we have to go with a new set of assumptions, a new mindset where no, you don't have to find the answer in your calculations. In fact, a lot of times you shouldn't. Like that would just waste time,
It take too
right?
much, yeah.
Right. And this idea of calculator is a good thing. I like to talk about it like in terms of the hypotheticals. Imagine if they did let us have a calculator.
Mhm.
Imagine the kinds of questions they could ask us if they
Right.
did allow us a calculator. The numbers would get insane, they'd get overwhelming, they'd really try to challenge us. But not having a calculator means there is always, this is not extreme language here that's inappropriate. There is always a way to make it more simple
Mhm.
because we have to recognize the exam writers know you don't have a calculator. They know that, and they make the questions in a way that it is doable without a calculator. If
Mhm.
you ever feel the need to say, I need a calculator for this, or this is too complicated for me to do, we have missed something immediately
Mhm. Mhm.
because we've either missed some rounding that we could have done, we could have missed some simplifying that we could have, and we'll talk about the steps
Mhm.
later. There is something we didn't do that we now have the opportunity to learn to,
Mhm.
but because we're not, that's why we're struggling. So not having calculator is a great thing because that
Mhm.
means these problems we can simplify them. We know there's a way to simplify them to always get an answer that works. Right? Always
Yeah.
there's going to be a case. You
Yeah.
just have to pick again the best one out of four. There's three that's going to be wrong and one that's just not wrong. Again, that's again going back to that MCAT question mindset. They don't always have to owe you an exact right answer. They owe you though. There's always three objectively wrong ones.
Yeah.
Um, right.
And
And like, I'm sorry.
I was just gonna say, and with that mindset in mind,
Mhm.
right? Like one of the best things that you could do for yourself if you get a question wrong is before you just look at the solution and say, how was I supposed to do this? You know how to do it. Again, if you know
Mhm.
multiplication, addition, subtraction, division, you can do this math, right? Look back over your work, reread the
Mhm.
question, see if you could work through it because there's probably something that we missed somewhere along the way. And I
Mhm.
bet you, if you are willing to try it again and to sit with it again, you'll find it.
Yeah.
You don't need the solution to help you figure out where you were wrong. You could figure it out yourself. And
Mhm.
that helps a lot too.
100%, 100%. And so I think with that mindset, if you have the proper mindset, that's when you can properly use question strategy. Because I think it's important that you change the mindset. Because and this is a reason I see a lot of people struggle with MCAT math is they keep their same mindset from before and then try to use the strategies is my big thing, right?
Yeah.
They keep the mindset from before. It's like, oh, I need to get an exact answer. I'm not
Mhm.
going to try this, and then they try using the strategy that we're going to talk about because we've worked with students one-on-one before. But because they're missing this mindset piece, this idea that you don't always have to get an exact answer, or like at the end, you don't always have to feel there's always a way to simplify. There's always a way to round. They're not going to get the most out of the strategy. So it really takes first solidify that mindset, recognizing there's always a way to simplify. There's always a way to make it easier and then we can jump into the strategy. But I think that's a good segue into talking about what is the strategy. I feel like we always tease our strategy. We always like tease like, okay, now we're gonna get to it. What the actual steps are to doing
Yeah.
a math problem.
Yeah.
And I think it's so funny. I think there's a step zero when doing a math problem,
I agree.
when doing a math problem, which is always read the passage first. Always read the passage first. I talk with students, especially like we do like one-on-one sessions with students who are thinking about tutoring. I do a lot of those ones, and I always like understanding because my goal is to set them on a path for success. I
Mhm.
talk with them. I ask them, okay, what is your chem phys specifically? What is your chem phys passage strategy? So many students say this exact same thing. I think it's
Frustrating.
on like Reddit, like it's somewhere, and it has like a whole bunch of upvotes, and that's why everyone does it. But it frustrates me so much. And they say, oh, I don't really read the passage. I just kind of go to the questions and then go back to the passage if I need. I swear, like an angel loses its wings every single time somebody says that. In my mind, and here's why. Here's why. If that strategy works for you, go for it. Do it. We can't tell you a
If you
thing.
get the great score that you
You get
want,
the great score, amazing.
never
But
change.
a
Keep
lot, a
it.
lot of people are not getting the score that they want. And they're thinking, well, I'm doing the Reddit strategy that other people used. Well,
Mhm.
again, strategies aren't universal, but a lot of the times you are falling into the traps because you don't think the MCAT knows people are doing that, that they're just gaming their passages, right? No, right? The reason that we don't want to function with this idea of skipping the passage to go into the questions really stems back to our core question strategy and our passage strategy,
Mhm.
where when we look at a question, we have to decide, is this just a straight content question or is it a passage-based
Mhm.
question? But are you able to actually ascertain that if you haven't read the passage?
No, not
No,
really.
not at all. Like you have no idea what's in the passage yet. You want to decide if something is in the passage or not.
Yeah.
A lot of times we think it's a content question, when in reality, oh, there was something really critical in the passage, a key equation in the passage, a key nuance that was in the passage, and that's why we miss questions. But then we decide, oh, well, this is the question strategy from Reddit, so let me just keep on doing that. Can't be the problem. No, no, let's change our strategy. We want to always read the passage first, not only for the key information that's there, but for the numbers, the values with units that are there.
Yeah.
Because for one, they serve to not only like you probably are going to have to use these numbers, so you want to know where to identify them in the passage, but they
Yeah.
also prime your mind. They also get you ready for the questions. A lot of people say, "Oh, I didn't know which equation to use. Oh, I saw this question. I didn't know which equation to use." But then the passage is all about electricity, about coulombs, about voltage, right?
Yeah.
All those numbers are there. And then the question asks about, oh, hey, what's the force? Oh, interesting. So
Yeah.
like it's like things like that where it's like the passage helps us for the questions. People see it as like a waste of time, and that cannot be further from the truth. So step zero for every math question is the step before you even get to the question, which is
Yeah.
read the passage first.
Yes.
Mhm.
Yeah, and make sure whenever you come across a value with units, right? So a
Mhm.
number, 10 coulombs, whatever. Make sure you highlight it.
Mhm.
Even if you're not someone who highlights often, we talk about it in our passage reading strategy. If you like it in science, go ahead, right? If you have a buzzword or a word or two that you like from the passage or that helps direct you, go ahead and highlight it. I do think for chemistry and physics, especially, which is where you're going to see most of the calculation questions, if you see a value with units in the passage, highlight it.
Mhm.
Okay, just because if you need it for a calculation, you don't want to have to go reread the passage. You
Mhm.
want to have read the passage already so you understand what kind of material could be used in these kinds of questions, but you want them to be quick and easy in terms of reference material, okay? Because when we get to a calculation question, what we're going to do is we're first going to read the question. Shocker. Make sure we know what we're being asked to do. And really, that's going to start with what am I solving for? And typically, you'll see this in one of two places. It'll say, like, what would voltage be if blah, 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 blah. Okay, it's voltage. You could also, though, look at your answer choices and check out the units of your answer choices. Okay, if all your answer choices are given in volts, you also know you're dealing with voltage, right? So you've got multiple hints in the answers and in the question for what you're solving for, and that should always be clear. Okay, you should always know what you're being asked to solve for, and you start there. But then once you have that, how am I going to get there? You have to
Mhm.
ask yourself, what do I have available? The key thing that I want to highlight here is how important it is to know your units.
Mhm.
Okay, if you don't know your units, that's why you don't know what equation to use. Okay, this is one of the most overlooked things I think that people have in preparing for chemistry and physics. They think memorize an equation sheet.
Mhm.
What is V? Is V voltage? Is it velocity? What is V? You don't, if you're just staring at an equation sheet, you might not know what the variables are in the equations that you're using. That's a problem. But you also need to know that volume is in liters, or, like you have to know the key unit that's associated with that variable, or else you'll have no idea to use that equation either, right? So make sure you pay close attention to the units provided in the passage and anything given in the question. Because if you figure out what you're solving for, that might rely on units, but also if you want to figure out how to get there, you have to recognize what you're given as well. Um, and then also, while you're checking out your answer choices, you can use it to help you figure out what you're solving for. But there's actually a lot of other value that you can get out of those answer choices in order to help you figure out how should I solve? And do I need a calculator or do I need to calculate at all? Do I need the math?
Mhm.
And how easy can I make the math for
Mhm.
myself? This next step is my favorite, but I know that you love it too, so I'm gonna let you share it.
So again, so to go over the steps that we've covered so far, one, we've identified the value that we're looking, because I mean, zero was go read the passage first. But
Zero is passage.
step number one, identify what you're actually looking for. A lot of people just don't know what they're looking for. Then, right, we glance over at the answer options to kind of give us a little bit of guidance, right? Looking at the units, right? That's our step like 1.5. Then step number two is identify what you have, right? What have you been given? But then step number three is what equation relates to these variables, right? You've identified what you're looking for. Now you've actually identified what you have. What's the piece that brings them together? Because the reason I love this is I want to make the what's the word? I want to make this question more like a puzzle. I want to make it fun. I want to make it interesting. Where if I can see, because there's always enough information. Always, always, always there is. That's something we have to be very clear. There's always enough information. Given the puzzle pieces that they've given me and the answer I know I'm looking for, what equation brings them together? Right? And I usually like thinking like, okay, what have I been given? And what is the equation that solves for that? Like if they give me like power, for example, right? I'm probably going to use my power equals work over time equation. I'm probably going to use that. And the key is like maybe you're given time, but not work.
Mm-hmm.
The equation that relates these variables doesn't always have to include all the variables you're given. But that's a great starting point to start manipulating things is the key,
Mm-hmm.
right? When we're finding which equation to use, it is so critical to do the first steps. Because it's so interesting, Molly, because you mentioned that a lot of times when people don't know which equation to use, it's because they don't know their units. We see that, but I also find a lot of people don't know which equation to use because they didn't even do the first steps. They didn't
Right.
even define what they're looking for. It's like
Yeah.
you're trying to figure out which equation to use, but you don't even know what you're trying to find. You didn't
Yep.
look at your units, right? Because step number one is to define what you're looking for. Then look at your units and your answer options. See like, okay, what am I actually? Is it work? Is it power? Is it voltage? Maybe it wasn't clear in the question. Well, the answer is going to make it pretty clear when you see the units. But then, what were you given? If you actually do those first two steps, finding which equation to use isn't actually all too bad because now you actually identified, you took the time to identify the hints that they gave you because there's always hints. There's always is there. This is not, and I think we talked about this in our question strategy or even in Psych Soc when you did that Psych Soc episode, that this is not a free recall exam. They're not just trying to like test your free recall of these equations. There's always a cue. There's always a hint when
Yeah.
doing these equations, or when when knowing to use these equations. But you just need to take the time in the first two steps to get those hints for the
Yeah.
equation. So
Yeah.
we start with what are we solving for? Then step 1.5, glance at your answer options in order to help you know what you're solving for. And also a note, and maybe I didn't make this kind of clear, look also how far they are apart from one another. Right? Look at actually identify like, oh, are my answer options close together? Are they far apart? Because this gives you a huge, huge hint in your rounding, right? I know, like, you were probably thinking like, oh, we should talk about the rounding. I know, I didn't mention how far apart. But because a
Which
lot
we'll
of the time,
talk about
which
too.
we will talk about that. Because if your answer options are really far apart, you can be a little bit more liberal with your rounding. If they're really, really close together, okay, I'm probably not rounding very much. I'm probably going to be using the exact numbers. But this is what's happening when we're glancing at our answer options. Not only are we helping us to look for and to know what are we actually solving for when it comes to the units, but also how heavily can I round? Identify that first before you start going ham at an equation.
Yeah.
Then identify what you're given, and then you've done the work now. The equation is usually the easy part once you've actually identified those things.
Yeah.
Mhm.
And again, a lot of people think, oh, physics, I'll just memorize an equation sheet. Psych social, memorize a vocab term. And it's like, do you need to know those things? Yes. Do you
Mhm.
need to memorize equations? Yes. But if you just stop at memorization, you're never going to get anywhere. Okay.
Mhm.
So again, we have to know how to put these things together. So we're going to identify an equation that helps us with at least some of what we have. And I just want to point out or suggest, right? If you're given a bunch of stuff, there might be a lot of equations that use the variables given. Okay, so what I want to point out, make sure that whatever starting point that you have includes what you're solving for.
Mhm.
Okay, so like if you're given, you said power and time, okay, or power and let's say speed. Okay, and you want to solve for power. I want you to think, what equations do I know that involve power before what equations do I know that involve speed or velocity? Because there are a lot of equations that use velocity, right? So start with, what equations do I know for what I'm solving for? That's usually the best place to go because that's ultimately what you need to calculate. So if you don't see one equation or you can't think of one that involves everything that you have, that's fine. Make sure you pay attention to what you're solving for. What equations do you know that involve that variable? Start there and then tinker, right? It's okay to not be, presented with a perfect option at the start. Okay. And although, right, most of the time you use all of the equations, at least or all of the values with units in the question, right? If you're given like 4 values in the question, you'll probably use them all unless they're trying to test you on something specific. And a good example would be like if we're talking about, let's say, buoyant force. They may give you the density of the object and the density of the fluid, right? And we know the buoyant force is the weight of the displaced fluid, right? So you want the density of the fluid, not the density of the object. We don't care about that for a buoyant force question, really. They might give you both to see which one you use.
Which one are you
That's an
gonna use?
intentional plant. They're giving you both because they want to see which one you'll use. Most of the time, if you're given values with units in the question, you're going to use them. Not all the time in the passage. In fact,
Right.
oftentimes we don't
You're
use
not going to
everything
use
in the
you're not going to
passage.
use every variable in the passage for one question, of course.
Yeah, but again, identify what you're solving for and then start to brainstorm what do I have available to me in my bank of equations in my head that at least has the thing I'm solving for. And again, try and use as much from the question as you can when selecting an equation. But if you don't see something obvious, just start tinkering, right? And a good example is actually one that we talk about in our free math session that we teach, right? And the example is about power,
Oh,
actually.
the power equation. Yes, yes, yes.
Yeah.
We have 2 power questions in that one, which is
I
interesting.
think I think we do, but this
Yeah.
one really illustrates what we're talking about. So, if a student pushes a 20 kilogram box along the ground at a speed of 3 meters per second by applying 12 newtons of force, what is their power output? So, in this equation, what is their power output? We're solving for power.
Step number
Okay.
1. You've done
That's
it.
step number 1.
Yeah.
Right? We know, and in this case, there's no passage. We have 20 kilograms, which what is the variable for 20 kilograms?
The variable, like mass.
Mass,
Yeah.
right? Again, you need to practice this. So we have mass. We have 3 meters per second, which is what variable?
Velocity or speed.
Mass, velocity, and then 12 newtons. And it
That's our
says
force.
of
Yeah.
force. Yeah.
That's correct.
So I'm solving for power and I'm given mass, velocity, and force. I don't know an equation that perfectly relates those
Fits
things,
that.
but I do know power, right? And like you said, it's work over time. So maybe I'll start there. Okay, power is work over time. Do I know how to relate work or time to anything that I'm given, which again is mass, velocity, and force?
Well, interesting, because I can't break time down really into anything.
Mm-mm.
But work we can. Because work, by definition, is force times displacement, force times a distance. So that power equals work over time. Because I don't have work or time, well, let me see
Right.
if I can simplify one of those values to make it, oh, work is force times distance. So now my equation, if I want to simplify that work value, is power equals force times displacement in the numerator over time. Now wait, this is great because in our answer option we have force. That's one of the variables
Yay!
we've got force.
We're in the right direction.
Let's go. So now when you find a variable that matches, in my mind, don't touch it. Don't touch it. You are now that we are not touching that variable anymore. You got it. But in our question, did it give us displacement or time in our equation?
It didn't, but
Yeah.
it's important to think about units again, right? Displacement is in meters,
Sure.
right? Time is given in seconds.
Mm-hmm.
Now, you don't have distance or time given, but you do have velocity,
Velocity.
which is distance over time, right? It's
Mhm.
meters per second. So when we have power is equal to force times distance divided by time, when I think of that distance divided by time, that's what velocity is,
Mhm.
right? So in that case, power becomes force
Mhm.
times velocity.
Mhm.
And I have both of those things,
Amazing.
right? So I now can plug that in and I could calculate exactly what I needed. And in this case, it's just 12 newtons of force times 3 meters per second. It's just 36.
36. Amazing. And
And
again,
that's
it was just multiplication. And
Yeah.
so this is a great example of what the MCAT will expect of us. They a lot of the times will expect you to manipulate equations. And the question I get so often is like, okay, I understood when the solution did it. When the solution changed
Mhm.
work over time to force times velocity, I can see how they did that. But how was I supposed to know? Is always the question that we get. And always my answer to that is always use what you're given to help you decide how to manipulate. You did
Yeah.
the work to define what you're looking for and what you're given. Well, when you didn't have all the things in your equation, that's your hint that you need to manipulate. That's your
Yeah.
hint. Use what you're given and say, okay, I don't have these things in the equation. Well, what do I have? And how could I put those in my equation? How can I manipulate this equation to do that? If you do that, a lot of times, we don't have to guess, right? It's not a guessing game. There's always a direction. There's always a hint in order to how to manipulate them. A lot of times we're just not looking for that hint, and that's why we miss it.
Yeah, absolutely. And again, I think it's important to call back to something that we had said earlier. In MCAT math, you should be doing as much work as is necessary.
Hmm.
Okay. Don't start tinkering if you don't have to. Don't
Right.
even calculate if you don't have
If you don't
to,
have to, right? In the
right?
first
Like
place.
do as much work as is necessary, no more,
Hmm.
right? So what we want to do, right? Once we've established what we're searching for, once we've established what we have available to us, we've picked an equation, keep the math simple. In this case, it was a simple 12 times 3.
Hmm.
Nothing too crazy there, right? That's pretty simple math, which is what we expect. And if it wasn't simple math, right? If we had like A times B times C times D divided by D or whatever, E times F, you've got like multiple terms being multiplied and multiple things being divided. And I've got to simplify this really complex, scary fraction. Pause. Is there any way that I could cancel some stuff out in the numerator and denominator? Can I round some stuff to make this easier? Once you've figured out what you're expected to do and the equation, you've set it up, now you're just doing the math itself. If it's not something simple like 3 times 12, simplify it before you engage with it too heavily because
Hmm.
you don't want to be, doing 5 long division problems on your scratch paper. It's going to take too long and you're probably going to make a mistake somewhere along the way. Okay,
Hmm.
so if your math, once you've done all this work, if your math still looks scary,
Hmm.
stop. Stop and simplify
Simplify.
because between the two of us, we did the so many of the video solutions for chemistry and physics
Hmm.
for the
Hmm.
AMC. And how many questions did you have that ended up being multiple major steps that you had to do all the work?
I honestly, I can't even think of a single
None.
question where I'd have to do like more than 3 lines, like more than like actual like that much math, where a lot of the work came from getting to the math. It's like, oh,
Yes.
identifying, oh, well, how could I have made it more simple? That's the work. The math is just the end part to wrap things up, not the whole problem a lot of the times. Um, and so and here's also one thing about like simplifying that's really, really good. It's always think to do this first because a lot of people kind of wrap this up where they think simplifying includes rounding. Like rounding and simplifying are the same thing. Where in my
Mhm.
mind, they're actually not, right? In my mind, where rounding is, again, we're just trying to ballpark our number at the end. So we want to round in order to make our numbers more friendly. Simplifying involves canceling things out. It's no rounding involved. It's like, oh, this exactly cancels. But a mistake I see a lot of the times is rounding before we try simplifying. And
Mhm.
that can be a really dangerous thing because sometimes the numbers are chosen in a very specific way to cancel out really nicely, but then we just
Mhm.
ruin everything by rounding. Right? We just like kind of like not again ruin everything is pretty extreme, but we make it actually way harder on ourselves. Like, a great example of this would be 42 divided by 14. If I just
Mhm.
look at that like straight up, I'm like, oh, let me just round 40 over 15. Right.
Mhm.
Right. Or so 42 over 14. Okay, now that's 40 over 15. But that's like now like okay, 15, like 30, like it's like 3.6-ish, right? Wait, it's kind of not great, but wait a minute. If I just tried simplifying, wait, how many times does 14 go into 42?
Couple.
A couple? Like exactly three.
Yeah.
Exactly three times. So I was trying to round to make it easier, but 42 divided by 14 is just three. It's just three. Like exactly. I mean, it's kind of one of those numbers that you don't really think about it. Like, oh, is it just three? It is 14, 28, 42. But because we thought first to round, I now had to do 40 over 15, which may on the surface looks easier, but it's actually like 3 point something, something, something. So instead, always first to think, when I'm given the math, I've set up my problem and it looks kind of scary. Before you start rounding numbers that don't look friendly, first aim to simplify before you round.
Yeah. And when I think of simplification, that definitely comes to mind. But also, especially when you have, like we said earlier, multiple terms multiplied divided by multiple terms in the denominator, right? Like if you had, and we actually have a bunch of really good examples of this in the free session. And I think it's too hard to give it all like
Hmm.
just with a voice only because it'll
Yeah,
be a lot of numbers to
it's
follow.
very visual. Yeah, yeah,
But
yeah.
let's say that we had three terms multiplied together in the numerator and three terms multiplied together in the denominator, right? What if, let's say there's a 300 in the numerator, and let's say there's a 3 in the denominator. Notice before I do all that crazy stuff, I can simplify I could simplify that, right? With the way that you set up the equation itself, when you're plugging in numbers, if we keep things nice and wrapped, or we keep it nice and simple, we put everything in scientific notation, right? So rather than 300, you'd have 3 times 10 to the 2. It now becomes really easy to recognize. I can cancel a 3 out in the top and the bottom. Right? That's what I think of with simplification. When you have a really big fraction or you have a bunch of stuff that you have to deal with, a bunch of individual mathematical operations, vast majority of the time you can divide or you can cancel things out.
Hmm.
So when I think of simplification, I think of canceling things out. Or even again, if we had to do a complex fraction, is there anything that I could do to make this easier for myself? And this one is one that I love to talk about, especially because can you round? Sure, right? Even in your example, 14 or 42 divided by 14, you could round that if you wanted to. You could do 45 over 15. That
Hmm.
gets you pretty close, and that's 3. That's much easier to see that it's 3. But what if you didn't want to do that, right?
Hmm.
Like, how else could you do it? Like, if you're given two fractions and you had, uh, you know, maybe 17 over 10 and 10 over 17,
Mm.
which one is easier to do?
Oh, 100% 17 over 10.
Right?
100% 17 over 10.
It's 1.7, right? You
Yeah.
just move a decimal.
Mm.
The take home from that is if you can make the denominator something close to 100 or
Mm.
10 or a
Hmm.
thousand,
A multiple of 10.
yeah, some multiple of 10, it makes life so much
So
easier.
much easier.
Right. And we do this implicitly. Like if I gave you 1 over 50, you could probably tell me pretty quick what that is a decimal,
Hmm.
right? What is 1 over 50?
Well, I'm like the 1.02 or something along those lines. Yeah. I know 0.02, I think.
Hmm.
Again, you're really testing me because it's 1.2 and then 1.02. Yeah,
Yeah.
yeah.
Right. I mean, 1 over 50, you could try and figure it out in your head, or 50, right? If I multiply 50 by 2, I get 100,
Yeah.
right? What I can do, because in math, you're allowed to multiply by
Both
1.
up,
You
both
could
top
always
and
multiply
bottom.
by 1.
Hmm.
Obviously, if I multiply 1 over 50 times 1, I'm just going to get 1 over 50.
Hmm.
That's not helpful. But keep in mind, 1 is also equal to 2 divided by 2. 2 divided by 2 is 1, right?
You are right.
I can take 1 over 50, and rather than just multiply it by 1, that helps me not at all. I can multiply it by 2 over 2. Now I get 1 times 2 in the denominator, which is 2, and I get 50 times 2 in the denominator, which is now 100.
Ah, I see.
Now
So
I
2
have
over
2 over
100.
100, which is equivalent to 1 over 50, but that becomes much easier.
Right.
That's much easier for me to do. And again, if it was 1 over 25, again, if I multiply 1 over 25 by 4 divided by 4, I get 4 over 100.04. 1 over 33, same deal. In that case, we can't get perfect.
Exactly, but you can get pretty close.
33 times 3 is 99. That's close enough to 100. Okay, so it'd be 0.03, etc. You can do this. Even if you have to divide by things that you don't like, can you multiply by 1, but again, some number over itself, 2 over 2, 4 over 4, 30 over 30. Can I do something to this fraction to make the bottom some multiple of 10? And if so, you can find any decimal place.
Any decimal place.
That's the beauty of it. There's so many options for you. Like if you were given 80 over 153, okay, you kind of have multiple options. Would it be better to round, or would it be better and easier to multiply top and bottom by something? I can't really think of something that I could multiply 153 by to get like 1,000. You absolutely can do it that way. But I'm also sensing that maybe rounding might be easier for this. 80 over 153, what would you do for that?
80 over 153, I would probably, again, and we talked about this during our math session about like a ballparking, but depending on what my answer choices are, I'd probably just make it a number I know, like probably a number that's easy, where I'd probably run that 153 to 160, because I know that, I don't know 80 over 153 immediately, but I know 80 over 160 is like exactly 0.5, because 80 over 160. And so if based on my answer options, that is something that like, oh, that's easy to pick. Absolutely. I also might try, like maybe I want to ballpark my answer. So maybe I like doing answers because I know 80 over 153, whatever number I get is going to be a little bit smaller than my actual number because I made the denominator simpler by making it a multiple of 10, by made it bigger. So I would probably also choose an answer option that I know is going to be bigger than my answer. That I know to ballpark my final answer. And this all really depends on what my answer options look like. Like it's very like, okay, depending on the problem. If my answer options are really far apart from one another, I'm doing 80 over 160 and calling it a day. If my answer options are a little bit closer together, then that's when I might like, okay, I know 80 over 160, my answer is gonna be a little bit bigger. Okay, let me choose a number I know that's also going to be bigger than 80 over 160, so I know it's going to be between 2 points. That's a little bit harder to visualize on a podcast. And so if you want to see this live, come to our MCAT math session Wednesday, every other Wednesday night. And so you can see that because I think depending on the scenario, both can be valid. Both are very, very valid. Just depends what your numbers look like.
Yeah. And I feel like this really underscores why it's so important to simplify before you round.
Yeah.
Because when you simplify, you're not actually changing the value that you calculate very much, if at all, right?
Yeah.
If you cancel out a 3 and a 3, the number you calculate is the same. Like it's the same number. You're not changing the value you get. But what you were pointing out of like 80 over 160, I've rounded. I've made the denominator bigger, which means my actual value is going to be a little bit smaller, right? I have to track that. I have to make sure that I keep that in mind. So that if I don't have 50, let's say I rounded to 50, but there was an option that's 51 and there's an option that's 49. I have to ask myself, will my number 80 over 160 be bigger or smaller than the true number, right? And so you have to keep track of that. And if you have a complex fraction, multiple numbers multiplied together in the top and multiple multiplied in the denominator, and I round all the time, how on earth am I going to be able to figure out if the number that I calculated should be bigger or smaller than the one that's on the answers?
Right. It's
like
hard.
there's no way because I've rounded
so
so many different times.
Right. And that's why we comes kind of back to before you round,
Yes.
aim to simplify. Simplifying doesn't change your number. Again, and I can just want anyone noticing how hesitant I am, like when it came to like the rounding. I was like, okay, well, depending on the scenario, this is what I would do. Whereas simplifying is like you can simplify to your heart's content as long as it's all valid algebraically, because your number's not changing. So there's no hesitancy.
Right.
There's a 3/3. Cancel that out yesterday kind of deal. Like make
Yeah.
it easier. Whereas rounding, we do have to be a little bit more cognizant. So that's not our first mental go-to, but a valuable tool nonetheless. Very,
Yes.
very valuable tool where
Mhm.
something like that, yes, we've glanced at our answer options. If our answer options allow us to round in a way, like they're off by orders of 10, yes, you can round that, 4.6 to 5. Like that's
Yeah.
okay, right?
Yeah.
Hmm.
I feel like one thing that we've hinted at and alluded to, but I want to say really directly, many students don't they struggle to simplify.
Mm,
Rounding is easy, right? Like most students are pretty comfortable with like the process of rounding. You see a number that's pretty close to another number that would be simple to deal with, just round.
mhm,
It's like we said, it's kind of the second round of defense, right?
mhm,
That's what we want to lean on if we can't simplify. But sometimes it's really hard to figure out how to simplify and to
mhm,
start building that as a tool. My number one piece of advice, if you want to start simplifying, okay, whenever you're plugging numbers into your equation, put everything in scientific notation. Again, if it's
mm,
300, it's 3 times 10 to the 2.
absolutely.
Okay, if it's 0.01, that's 1 times 10 to the minus 2. Put it in
Hmm.
scientific notations and make sure that your SI or make sure that your unit is standard. So if you have millimeters, if you have 1 millimeter, that is 1 times 10 to the minus 3 meters.
Hmm.
Don't put millimeters in there. Unless you have millimeters in your answer choices,
Hmm.
make sure it's in standard units,
Hmm.
especially like, when we were talking about the work equation, right?
Hmm.
Or the power equation that ended up being force times velocity.
Hmm.
As long as I have newtons for my force and as long as I have meters per second for my velocity, I can have confidence that that's going to end up being the normal unit for power, which is watts.
Hmm.
If I had kilonewtons, I no longer have watts, I have kilowatts.
Hmm.
So you have to be careful, okay?
Careful with units.
If you want to have confidence with your selection of units, you have to put everything into the standard before you plug it in to calculate. Okay, so super important. Like we said, the setup for an MCAT math question is 90% of the work, if not more.
Truly.
Once you have the numbers plugged in, it's fast from there.
Hmm.
It's the exact opposite of how most of us are probably
Hmm.
approaching this, spending the
Hmm.
vast majority of the time on the calculation itself.
Hmm.
That's the fast part, right? Because the actual setup, you are taking care of all the different ways that you could get confused and get lost along the way. And that's the beauty of it. So
Hmm.
I just want to remind you, if you want to get better at simplification and maybe lean a little less on rounding and therefore improve your accuracy a little bit, everything goes in SI units before
Hmm.
it's plugged in, and
Hmm.
everything goes in scientific notation. Then you're
Yes.
going to be able to watch everything cancel,
Oh,
and
it's
it's a
so beautiful. It's
beautiful
such
thing.
a good feel. Like when you
It
cancel out like
feels
a
so
whole,
good.
it's so, I don't know, there's something cathartic about like just getting rid of numbers with confidence is the thing. Because a lot of people, I think, as soon as crossing out happens, there's like a little bit of uncertainty, like, oh, can I do that? Like with the confidence of knowing that you can is huge. It's
It's
absolutely
amazing,
massive.
especially when you struggle with it for so long.
Exactly. And then a lot of people are like, oh, how do I improve that? Like, okay, so I need to maybe you're not used to it. You're like, Molly, okay, I hear I'm supposed to do SI units and put it in a scientific notation. Okay, how can I work to think that way? It comes with doing it. Between you and me,
Practice.
Molly, we've done thousands upon thousands of questions of these problems to
Mhm.
make it so that we don't have to think about it. It just happens. Like
Mhm.
when you put, I don't think I ever will ever write 3 million again. Like generally it's 3 times 10 to the 6, like every single time.
Yeah.
Like as soon as that's the case, I have more than like 1 0. Like 30, I might keep it as 30. But as soon as it gets more than 1 0, it's going to scientific notation, like
Yeah.
immediately. And so that comes from practice. That's not oh, we just were born this way. That's why how we're
Yeah.
wired. Intentional practice, not just practice. I hate is a strong word. I don't like the word practice at periods,
Yeah.
full stop. Because
Yeah.
and I'm sure you've seen this, Molly, I've seen people do so much work. We'll do every
Hmm.
single Jack Weston problem, every single AMC problem, every single UWorld problem. And they're like, oh, I still struggle after doing all that practice. It's not about just doing practice. It's about
I
doing
know.
intentional practice. Ah, the word's
There's
there.
that word
Right, right.
intention.
And what does that mean? It's like if you are not making an effort to be really intentional with your steps and in your process, constantly aiming to improve that, practice is useless.
Yeah.
Genuinely. And I know that's extreme. Of course, there's some utility to it. But if you're doing the same thing over and over again and expecting a different result,
Yeah. I
not
mean,
going to
I
improve.
think it comes back to, and we've talked about this at so many different points throughout our podcast, like so many different points, but like everything that you do
Mhm.
in the MCAT space, every way that you study, every tool that you use has a purpose.
Mm,
And as people obsessed with learning design
mm,
like we are in tune with that, but most people are not. A practice problem is not a teaching tool. You are not learning just by doing a practice problem. Okay. Just by working through a solution, you are not inherently learning. Okay. It's a testing tool. You
mhm,
are testing your knowledge, your strategies, and your ability to navigate this. The learning happens when you're done with it and you're trying
mhm,
to figure out how did I do? That's the
mhm,
learning element.
mm,
Okay, so just drilling questions and doing a million of them, and I have 60% accuracy. Drill 100 more, I still have 60% accuracy. Drill 100 more, I still have 60% accuracy, or
mm,
maybe it's
mm.
55 now.
My
You're
heart's
not
hurting hearing this.
you're
My
not
heart.
learning anything from
Mhm,
drilling, right?
mhm,
So the intentional aspect of this, and it calls back to something that we talked about earlier, know that you will have to do this timed. You will have to do this without a calculator. I want you getting practice with a time frame, a time limit, right? Maybe you start out, depending on where we're at, maybe you start out with a minute and 15 seconds. Maybe then go for a minute. Maybe then, if you're starting to pick up strategies, maybe you do less. Timed practice first. But if you just hop right to the solution, you will not learn anything, unfortunately, right? You do a timed exercise to get comfortable and to force your brain to look for shortcuts. And then you look at it again without a timer. Okay, I did this calculation question. I tried to simplify it this way because I knew I only had a minute to do this. Now that the timer's gone, is this valid? Before you even look at your answer, is what I did okay? Check your work. Did I make a rounding error? Did I do this or that? Like, am I happy with my answer? Then you check your answer. Okay, only after you've seen it in a rush and you've been forced to try and develop those tools, and then you see it again and you give yourself the freedom to work through it again, right? Did I do this effectively? That step, you learn so much. Then when you check your answer, if you get it right, that reasoning that you did, you already did the solution. You don't even need to look, right? Because you
mhm,
already went back and basically found your own system for doing it. You could read the solution, of course, but what you did worked. Great job. Keep doing that. Right now, you have takeaways to use for next time. Let's say you worked through it all and you still got stuck. Okay, without a timer, look at the solution. Now you know this was not a timing issue.
mhm,
I just gave myself as much time as I needed and I still couldn't figure it out. This is a question I need to focus on. What happened in the solution? How was I supposed to work at this? Give yourself a couple hints, right? You could read the solution and look at your work until you find something you did differently. Once you find that, I treat that like a hint. Now I pause. I'm not going to look at that anymore. I realized I made a math mistake here. Let me finish solving. Okay, I realized I made that mistake. That was my issue. Finish solving. Do I now get the right answer? Right?
mhm,
Treat the solution like breadcrumbs if you struggled in that untimed attempt. If you
mhm.
really want to learn how to do MCAT math and you want to build the skills that we've been talking about, you can't just do a practice problem and look at the solution. You will
Oh,
never learn because
yeah.
that's not what practice is meant to do. It's the review. Um, and the solutions, like you said, typically just give the pure mathematical answer. There's no tips and tricks and ways to simplify. You have to learn how to do that on your own. Or
Mhm.
look at the Jack Weston solutions, which
Oh,
typically will show the
so
the
some
secret
like different
sauce,
way to
but
do it. Yeah, yeah.
but
And
you want
I
to learn how to do that on your own too. And that's
right,
the best way to
right.
be intentional there.
And I think there's something that you hit on that I really want to stress is how you use the solutions. Because like we said, the review is so important. But I don't want anyone to come away with like, okay, as long as I'm using my solutions, I'm reviewing after I'm doing. But how you use that solution, I think you just did it wonderfully, where when people like get a question wrong in terms of math, they just read the whole solution and now they've learned nothing. They're like,
Right.
oh, that's how they've just given me the whole thing. Great. But I want you to use the solution as right, like a hint. It's like, okay, where, as soon as you like start reading and you see something different, now stop reading the solution. Now, was it that all that, it was the hint all that you needed? Okay, what could we have seen in order to get that hint in the future? We can start
Mm,
strategizing. But as soon as we just get the question wrong and look at our solution, we're like, oh, now we've taken all the learning away. We haven't learned a thing now. We've just
yeah.
gotten the answer, we've got handed it to us, but that's not transferable to a new problem because they're not going to give
Yeah.
me the solution for a new problem. So how you use the solution, I think you put it wonderfully, Molly, where you want to use it as a hint to grow, not as like a, oh, what, to feel bad. Oh, that's the mistake I made.
Yeah, and so often I literally see this all the time, and I'm sure you do too. Students will say, "Oh, I'm bad at thermodynamics."
Mm,
And it's like, okay, why do you say that? And they're like, well, I always get the math questions wrong. Or, I got a math question wrong on it recently, so I'm bad at thermodynamics. And I'm like, okay, let's walk through that question. That student was able to find what they were solving for. They knew all their values with units. They got the right equation and they plugged everything in with, the values given in the right way. They were not bad at thermodynamics. The thermodynamics part is over. The thermodynamics specific part is recognizing what you're solving for, recognizing what you have, finding the equation. From there, that's a calculation issue,
mhm,
right? Maybe we didn't put things in scientific notation. Maybe we didn't put them in SI units, right? The
mm,
base normal unit for that variable. Or maybe it was I simplified differently or I rounded differently. If
mm,
that's the case, that has nothing to do with thermodynamics anymore.
mm,
I've already taken care of the thermodynamics part. Now it's just pure math, right? Maybe we didn't put something in SI units. Your issue is not thermo, right?
mhm.
I just need to be more careful
Math,
with when I plug things in,
right.
right? So you might find that you think, oh, I'm bad at physics in
XYZ
general,
content,
or I'm
right.
bad at, yeah. And sometimes it is. Maybe
Mhm,
sometimes we struggle with thermodynamics units or something like that. Okay, that is a thermodynamics issue. But that's why you don't just do a question and then look at the solution. If let's say let's say you didn't know the question or you didn't know the equation to use. Okay, go to the solution, find the equation, pause. Can I do the rest? Now that I have that hint, maybe still no.
mm,
Maybe it was the equation I didn't know, so I need to review thermo, but then still trying to do the math, I got stuck.
mm, mhm,
Now, pause again. Do I have another hint? Maybe we have multiple things we need to work on.
mhm,
One of the biggest gifts you can give yourself is the ability to be specific with
mm,
what you need to work on.
mm,
Because if you just say, I'm bad at calculations or I'm bad at chemistry and physics, notice that there is no obvious way to work on that. Like if a student tells me in general office hours, I'm bad at chem phys, I'm like, if that's
okay.
true,
Mhm,
you've got months of work. You've got to relearn every topic, you've got to relearn every skill. But it's not true. You're not bad at everything. You're bad
mhm,
at a couple things and you're generalizing. The ability to get more specific
mm,
is a gift because if you know that you struggle with SI units, that's so specific. You could go in, review SI units in an afternoon and you're done, right? Like if you struggle with simplification, you can do some extra practice, review it the way that we talked about, and you can build that skill in a couple days, a
mhm,
week, right? Like it's get as specific as you can.
right.
Also because it helps get off that self-fulfilling prophecy
Of I'm
that we
bad at
mentioned
this, I'm
earlier
bad at
too.
this, right? And also
Improves
makes it way more
confidence.
actionable, right? Like if I say, like
Exactly.
you were saying, as soon as you identified, oh, I'm bad at SI units, you knew exactly what to do now. Oh, let's work on our
Exactly.
SI units. If I'm saying I'm bad at Chem Phys, I'm like,
That just makes me
what
feel bad about
what
myself. Like
action,
that
yeah,
there's
what
no
actions can we take? So I think anyone, and that I think this is just generalizable to even outside of math, MCAT math, but just on really anything. This is even outside of like the MCAT. Whereas if you're struggling with something, a lot of times a lot of our fears are founded in the generalized
Mhm.
space. Whereas as soon as you
Yes.
get really specific, like, I'm not bad at, or maybe we say I'm afraid of, going out to meet new people. Again, that's just but okay, no, but like, why? Or let's get specific on that. What about it is it? Oh, I'm afraid of X. I'm afraid of Y. I'm afraid of Z. By getting more like specific as to what's actually giving us a struggle makes it way more actionable to achieve whatever
Yeah.
goal. But zooming in back on MCAT math, yes, you're probably not bad at math as a whole. There's probably just one or two things that you're struggling with that come up often that makes you feel like you're bad at math, MCAT math.
Yeah.
But as soon as you work on that very specific thing, the improvement is exponential sometimes.
Yeah.
And I think there's a lot of kind of things that we talked about today in terms of mindset, in terms of plan. But everyone who's listening, the real key that we want you to take away is do it, right? Take what we're saying and actually apply it. It's not enough to just listen to us and now you're good at MCAT math. No, no, no. And math on the MCAT really is you have to put these things into practice in order to see the improvement yourself. And
Yeah.
there's so many things, even today, we were talking about this before, Molly. That's so much that we wanted to include in this episode today
Mhm.
that is just so hard to include in an oral, like in an oral podcast that we're like, oh, we want to show you this cool trick. We want to show you, hey, look what you can do with these like bases, for example, a little hint, that we couldn't include today because we just feel like it would have been too hard to do
Auditory.
or,
Yeah.
or do auditorily. So if you are looking for those things, if you're like, oh wow, this is really cool, and you want
I want to talk
more kind of
logs.
tips and tricks, talk logs. Oh my goodness, I want to talk logs.
Yeah.
Check us out like at our on our website. Our free trial sessions is called Secrets to MCAT Math. I host it usually. I'm actually gone for a few weeks, so Molly will be taking it over and doing a fantastic job for it with it. And so come to the session. You'll hear a lot of these same things, but also see them applied. Watch us apply these problems to all sorts of scenarios and also learn some genuinely really valuable tips. So I highly recommend coming and checking that out.
Yes, for
Yeah.
sure.
Mhm.
Yeah, and there's so many opportunities to get practice. You could use our free Q bank as well. If you want
Mhm.
generalized practice, you could just sort by AMC style. We'll give you a
Mhm.
mix of any chemistry and physics topic. Or if you want to use fundamental questions, which is specific to a topic, you could go in, you could say physics, fundamental questions, and I specifically want to do it on maybe something like forces, energy, and power.
Oh, hey, hint,
Could be a
hint.
good idea to get some practice.
Right. And
Maybe we'll
also
talk about that kind of soon.
in the next episode. So yeah, so if you haven't guessed it, our next episode, and I'm actually really excited because we haven't actually talked like a straight physics one in a while. And
Fluids, but that was a while ago.
Fluids was like our very first episode, you and I together when we
Mhm.
talked content. And I love physics. So I'm really excited to chat forces, energy, and power next episode because I think especially the energy, oh my goodness,
Yeah.
it is everywhere in chemistry and physics. If
Oh,
you
yeah.
understand energy, that's foundational to so many
Yeah.
content areas.
You
Actually
can
understand
understand
it.
fluids and light and sound and
Like it's literally everywhere. So that's why, and I just love it as a concept. And so
yeah,
I'm really excited to talk about it next episode.
me too.
Yeah.
So stay tuned. We hope you enjoyed this episode. Lots and lots of practice. Don't forget. And we hope you stay tuned for our next episode. Forces, energy, and power. We're getting back into physics. We're
Love
gonna
it.
have a grand old time.
Grand old time.
Have a lovely rest of your day, everyone. And we'll see you soon.
Happy studying.
Welcome to the Jack Westin MCAT podcast with your hosts, Michael Maleka
And Molly Hudash.